Tetravalence of carbon, shapes of organic compounds. In grade 10, you had learnt about the unique property of carbon and why it forms so many compounds in the first place. This is just a recap on that. So catenation is the ability of carbon to form long chains, and by self-linking. So which means this is a long chain, and this could also be a branched chain, or it could be like this. But the point is, these are all pretty stable. Of course, you need to add hydrogens to balance out the valency, but carbon is able to form such long chains. And this has in fact led, this ability of carbon being able to form long chains has led to the synthesis of compounds called as polymers. Polymers are the long chain long carbon chains which are present in plastics. So this property, that is catenation, can also be explained by the fact that the amount of energy that is required to break the carbon-carbon bond is 335 kilojoules per mole, whereas for silicon it's 220 kilojoules per mole. Whereas for germanium it's 167 kilojoules per mole. So the amount of energy that is required to break the bond between two carbon atoms is quite high. The other thing that led to so many compounds being synthesized which have carbon in it is the fact that tetravalency. So let's see, atomic number of carbon is 6, right? So the electronic configuration for carbon is 1s2, 2s2, 2p2, which means you have this shell is full, this orbital is full, then you have like this. So the number of electrons carbon requires is 4, okay, and the amount of energy that is required to form C4 plus or C4 minus is extremely high, and that is the reason why carbon generally does not form ionic compounds. Because it is quite impossible for this particular atom, that is carbon, to lose 4 electrons or to gain 4 electrons. The amount of energy that it requires for this to happen is extremely high. So, to fulfill its octet state, carbon instead shares its electrons, and this leads to the formation of covalent bonds. So what happens is, to complete its octet, let's take carbon, okay. It has 4 electrons in its outermost shell, right? 1, 2, 3 and 4. 2s2, 2p2. So it has 4 electrons. So it binds with 4 hydrogen atoms, and each hydrogen atom will have 1 electron. Okay, so what happens is, so each hydrogen atom will also fulfill its helium configuration, and this leads to the formation of a compound called methane, which is CH4. So carbon can form 4 bonds, and so this is because it has it cannot form an ionic compound due to the fact that the amount of energy that is required to form a C4 plus or C4 minus is extremely high, and because of that it tends to form covalent bonds, and covalent bonds are formed by sharing of electrons rather than donating or rather complete transfer of electrons. So usually in all our organic compounds from now onwards, for you to remember, you need to remember that each carbon atom will form 4 bonds. So in this also, like suppose let's take like 3 carbons together. Now to fill out its octet, we will be having 3 hydrogens in the first carbon, 2 hydrogens in the second, again 3 hydrogens in the third. This shows that each carbon atom has 4 bonds. So there are 2 properties that we learned about: catenation and tetravalency. Catenation is long chains by self-linking of the same atom. Carbon's long chains are pretty stable, and tetravalency is basically the valency of carbon, which is 4, and because it's quite, I mean, it requires a lot of energy to form ions of carbon. It leads to the formation of covalent bonds. In the next video, we will be studying about the shapes of organic molecule compounds. Do check it out.